This is Professor Bol. He's from Harvard University. And today he's going to be talking about his exciting project, the Chinese Biographical Database Project. Uh, yeah, we're really excited to have you here, and we hope that we learn a lot through this guest lecture. So thank you so much for coming and taking the time.
Okay, good. So I'm gonna really be focused on this much more than on the digital humanities generally, but let me begin by sharing a screen, as we all do nowadays. You have to enable my screen sharing. You have to make me co-host.
Oh, sorry about that. Yeah, let me see. Okay, so I think I made you co-host. Are you able to do it, or?
I am.
Oh, cool.
Let's see. Inbox, Chinese cultural history, show all windows. We got to show all windows here. Yeah, there we go. Okay. And let me blow that up. So it's always seemed to me that there's a, in the there are things we know from more analog procedures, and that in the digital humanities, we still have to make certain kinds of conceptual leaps to see the difference between, for example, a paper map and a geographic information system, or a spreadsheet, or a table and a relational database. And so one of the things I want to talk about, now there are two sort of big things you might think about within digital humanities. One has to do with writing, right? And for most people, writing is the focus of digital humanities work. And clearly we could agree that you can understand writing in two contexts, right? Writing reflects the thought of that writer, but it also is related to the total set of writings at a certain point in time, right? And the same thing could be said of an individual's life and action, that an individual's actions can be understood in the life of an individual, but they also have to be seen in the total set of actions by actors at the time. In some sense, the total set of actions is makes an individual act legible. So in this sense, when we talk about big data in language and in persons, right? In big data, we understand words to exist in the network of language of the times, but also as the product of the mind of the speaker. And when it comes to persons, we understand acts in relation to the larger life patterns, but also in relative to an individual's life story. And I'm going to be talking really, after this one slide, about topic modeling, really talking about how we think about life stories as big data. And some of you may know topic modeling, but because I have less time today than I planned, I think I won't talk about this, except to say that I think topic modeling on a large scale is proving its value. And I expect to see much more there. So I'm really going to be talking about modeling life histories. And the point is made that in many ways, information about people consists of anecdotes. But when you compile lots of anecdotes, it becomes data, right? And that's what makes data interesting. China, in this case, is an interesting place because we have a 2,000-year record, at least 2,000-year record of elite biography, beginning, I'd say, well, 2,100 years with Sima Qian's Shiji. We probably have 250,000, 250,000 detailed biographies. But if we look at local histories, Difang Zhi, local gazetteers, probably another 2 million. Record of compiling genealogies, jiapu, in Chinese history. And so in that sense, to look at Chinese history is to look at one of the major sources for the history of humanity. And what the China Biographical Database tries to do is to make it possible to take these lives and turn them into data, the anecdotes about people's lives, and to make this broadly available. You can download, you go to the China Biographical Database Project, it's open, free, you can download the whole database, you can read all about it, et cetera, et cetera. And of course, it's a multilingual database because it has to have Hanzi, Chinese characters, and Pinyin, the romanization system, but also in some cases English translation, because we're serving a worldwide public. And you can see our recent users over the last month or so. It looks something like this. Its data is its ongoing project, right? It has around 470,000 people in it at the moment, but they're not evenly distributed. And by and large, the distribution begins in the Tang Dynasty on the left in blue in the early 7th century and goes into the 1910s and 20s, the Mingguo period on the right, with an enormous amount being in the Ming, which is 1368 to 1644 for various reasons. Now, just having lives of people isn't enough. You have to categorize the data in them for it to be useful. I'll have much more to say about that later. And so we collect information about persons, about where they were, places, where they were born, died, visited, had friends, served in office. There are various names. China and Chinese history, people have multiple names, although we're very fortunate that early on in China, people gained surnames, right? What in Chinese is called a xing, because surnames come very late in Europe. And so if you look at, for example, the prosopography of Anglo-Saxon England, which is basically later than the Tang Dynasty, they don't have surnames for most people. And so they have to do things like Frederick 233 because they can't figure out who all these Fredericks are. In any case, people in China, many people serve in government, the people we know most about. They entered government, they entered into office in a particular way, often in the later period through examinations. They're related to other people. They have friendships of various kinds, associations, non-kin associations with other people. They produce text of their own, and they have their a general identity, like somebody's a monk or a poet or something like that. And this is another way of looking at that same sort of thing. Now, I want to cover sort of 4 aspects of these conceptual leaps very quickly, and then talk a little bit about what makes a relational database important. And the 4 aspects are going to be beginning with text mining. Because in fact, the way we get information, we extract information from Chinese texts is using computational methods, a method called regular expressions, which we write up in Python. And basically we read digitized text, searchable text, and we extract different kinds of information. And so this is an example. Each color represents a different kind of information. You can look at it in Chinese or you can look at it in English. So yellow refers to names of people. Green refers to offices, like president or governor or something like this. Blue, the light blue, turquoise blue refers to kinship relations. The dark blue to places. The purple to a social association. The red to entry into office, and so on. And so here in 2 sentences, 3 or 4 sentences actually, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You have a whole bunch of data points. Each one of those gets logged separately. But using computational methods, it took us around half a year to develop the methodologies. But using computational methods, we were able to read 25,000 biographies in half a day versus 5 years doing it by hand, right? The next thing is prosopography. Prosopography is basically a name for an approach to history that looks at large groups of people. And it's fundamentally a statistical approach to try to figure out what the significant variables are that might explain different behaviors. But here's an example of doing that, a very simple one. This is age at death. You've probably all heard this nonsense that people in the pre-modern world only live to 35. That's utter bad statistics. It's based on which is the major cause of death in early ages. But once you live right particularly into your teens, you're more or less indestructible. And the average age, the median age is around 63, right? 1,000 years ago, 1,500 years ago, 100 years ago. The real change in modern times, in the 20th century, has been cutting back on infant mortality and geriatric medicine. In other words, rather than having just a few people live to their 80s and 90s, lots of people live into their 80s and 90s. But here is a different thing. When we extract women from that record, this is what it looks like when we look at age, the distribution of age at death. And so, why is that? Why is that? I'm going to call on somebody. Richard, you're first. How do you account for this distribution? And then Claire, you're second.
Who knows? Bimodal distribution is very strange.
Yeah, because the first distribution is like this, right? Which is a nice bell curve. Beautiful, right?
Right. Like, I don't know, I'm just guessing here, possibly due to childbirth. Like, there could be complications.
Claire, what do you think?
Yeah, have the same death, like mortality from childbirth.
That's exactly it. And this is, we were publishing an article in China, and the editors were very upset. They didn't want us to show this chart. And we tried to get them to understand this was not insulting China. This is true across the world for the pre-modern world, right? A significant number of women die in childbirth. That's prosopography, an example of prosopography. The next is spatial analysis. It is, how do we take data and put it on a map using computational methods? And for those of you who are interested in spatial analysis and geographic information systems, you can, I'll tell you more about that in a second. But in this case, these are the people who are in the China Biographical Database. This is the distribution. You'll notice that it is not an equal distribution, right? Spatially, there are areas which are more heavy than others, and areas which are, even though the land is flat, have very few people coming out of it. So here's another example of that. In the Tang period, from these places, you go to the next dynasty, and it looks like this. Right? So between the two, what we've seen is a changing distribution of the Chinese elite, right? And that's what's sometimes called the medieval revolution, as South China starts to become half of the Chinese population. Now, GIS is interesting. I'll just say a few words about that because I really am interested in GIS a lot. You can have what's called a digital elevation model, which basically is every pixel on the screen is given a color. And the color creates the illusion of depth and height, right? With the notion of shading and things like this. The other kind, and so this is called a digital elevation model or raster data. Each pixel has a value. But the other kind of data is vector data, which is basically points. And imagine an XY grid, and XY is longitude, latitude, and then we have a point. And if you have 2 points, you have a line. And if the line crosses back over itself, it's a polygon, right? There are no circles. Everything is a line, right? is a straight line, except the straight line may only be a pixel long. And so you can take points, lines, and polygons and create a map like this, if you have the data. And then you could take your digital elevation model and put places, locations on that. Or we could put a river system on it. And then we could put the places and river systems. And once we do that, we can do all sorts of analysis. We can say, how many of the places are on the north side of rivers? Are the larger places in red? Are they where two rivers join together, right? Whereas smaller places may be only on one river, and so on. If you're interested in GIS, you can download all these data sets, spatial data sets, not the, this kind of information. Rivers, locations, polygons, you can download that all from the China Historical Information System, which Harvard and Fudan University in Shanghai did. Then we have social network analysis. I suspect by this point, most of you have heard of social network analysis, but here's a simple example. If you look at each one of these dots as a person, and the size of the dot represents the number of persons somebody is connected to and how central they are in those connections. So this guy, the big dot in the middle, different groups, right? This group on the left, everyone is connected together, but they only connect to people on the other side through him, right? So that's the basic idea of social network analysis. But we also see that there are clusters, right? So it's the same data as this, right? But now we're just looking at the clusters or subgroups within the data set. And that's basically network analysis. And you can do fancy network analysis like this, which is looking at intellectual literary connections, only people from one prefecture. So one prefecture would be, let's say from Palo Alto north along the bay to San Francisco. That's around the size of one prefecture. And so these are people from the 12th, 13th century and their connections together. So, and this goes on to a later date, the 13th into 14th century, right? And obviously, when you have so many people, right, there's not much use. And so here I've used network analysis programs to basically say, show me only people who have at least 7 connections to other people, or at least 7 other people that they're connected to. And that lets us start to say, oh, among these people, who are the important people? Well, Songlian must be very important. Huang Jin is important, Liu Guan, Wang Wei, Dailang, and so on. But network analysis really is mathematical. And so what you want to do when you're looking at network analysis is look at the tables, look at the data tables and that measure different kinds of centrality. Because there are many different kinds of centrality. And then you can start to really figure out what's going on. But network analysis, and this is important to keep in mind, different kinds of analysis show different things, right? Network analysis shows you connections between people, but it doesn't tell you anything about where those people are. This is the same data set, this data set, now put on a map. And all of a sudden you see that this guy Songlian, that his associations really are within one province, and down into another province, into Jiangxi, what's called Jiangxi, and then in Zhejiang. Right? So now we get to the heart of the matter. Abhinav, what time is it?
Right now it's 10:23.
Okay, good. So what I'm going to do now, how many of you have worked with relational databases before? How many of you worked with relational databases? Let me look at all of you. Oh, there are only... Anyone who's worked with a relational database? How many of you worked with a spreadsheet, an Excel sheet? Okay, so now what I want to persuade you to is that Excel sheets are nice, but not as good as relational databases for doing interesting things. So all the things I've shown you, all the data sets I've shown you are all generated out of a relational database. All the people, right? Whether I'm putting them on a map, whether I'm looking at looking at them through social network analysis, whether I'm looking at them from a statistical lens, they're all generated out of the same relational database. And that's the China Biographical Database. So there's a really question, how is it possible that we go from individuals living here who have the surname Zhuge, which we have a good number of, and have in this nice old village, right? Or here up in the mountains, or here in a ritzy home, fancy home of a well-to-do family that goes back to the 14th century. How do we get them all connected together if they have connections? And that's why CBDB is a relational database. And so you can download the whole database, and we've actually built standalone queries, or we've built queries in the standalone database. So if you don't know how to run queries, you can do it. Use this. And so I could go and query office holding, query kinship associations, and so on. And I have multiple variables. I have time, I have place, right? I have the nature of the office. I can look at individuals or groups, right? And then I can export to different analytic software packages. And, then we also have to do it in different kinds of encodings like this. And a relational database basically takes different kinds of information and puts it in tables. So I might have a table that consists of nothing but different kinds of different names of people, a table of places, a table of offices, the titles of offices. And so I can link up a person to a place to an office in a relational database. Now, so here we have an example. This would be typical of somebody who's doing this in a spreadsheet. And so you're collecting biographical data, and you're looking at this man named Sima Guang, who is the greatest historian of the 11th century. Serves as prime minister for a while. And I might say, okay, I have his name. So in this cell, I list all his offices. In this cell, I list all associations. This is a bad idea. This is a bad idea. And so when we're talking about trying to figure out data and about people, the reason for doing a relational database is we want to be able to distinguish different kinds of data in different ways. So one way I could do it would be to create multiple tables. And each time I write the name Sima Guang, I give the date, and I give the office. Next, right? His name, the date, the office, and so on. Or his name, the association type, and the person that he's associated with. That's one way. But that's really, really inefficient. Really inefficient. But it has one advantage. Suppose I had one table that listed all the people and all the offices. I could search and say, tell me everybody who was a budget auditor, right, in this year. But I'd still have to do an enormous amount of typing to create those tables. Moreover, what you see here, as you see that there's duplication. So there are many people who served as budget auditor. Sima Guang, just looking at Sima Guang, people he wrote sacrificial prayers for are many, right? Why would I want to keep typing this again and again and again? Because I'm guaranteed to make mistakes, right? If I have to do that. And so what I do is I create code tables. And this gets us the first important distinction in a relational database between code tables and data tables. A code table tells me the value of a code, right? So here is the code or the ID for people. And Sima Guang is number 1. And here's the code table for office titles. and the code table for association types. Once I have code tables, I never need to type Sima Guang's name again, or the name of an office again, or the name of an association again. I just, and you're not as if it's not that you're going to be doing the numbers yourself, right? You don't have to remember 10,000 numbers. You use various other computational methods to basically call to get this right. But now I just have to say for postings, 1, and then the year, 1, 2, and the year, or association types 1, 1, 2, 1, and so on. So once I've done this, it also makes the database light. 470,000 people in the database, but a couple million data points. And we expect in the next 2 years, we have around 4 million new data points coming in. So we really have to have something that's fairly lightweight. We can't waste the space on typing those names. And so now you see sort of a very brief summary version of how a relational database works. You have your main biographical table right in the middle of the biographical main. You have a person ID and information about that person. And that connects to postings to offices. And so you have a person ID and a posting ID, an associations table, right? Which draws on those things. And we have addresses, biographical addresses, alternate names, and so on. Many, many different ways of looking at people and connecting them together. And so you end up with a relational database that you can start to cross-reference people. You can look at people and places, and you can jump from one to the other. You can group them together. So I can do something like this. I can say, tell me all the people who came from a certain place. Now figure out which ones of them passed the Chinese civil service examination. And of the people that passed between year 1 and year, let's say 2, or year X and year Y, how many of them were related to each other by kinship? And that's what a relational database can begin to do. Or you can say, I'm interested in painting and I want to know who was the student of which painters, and where did they live? And did painters of a certain kind of painting group in one place? Or did the authors of certain kinds of books come from a certain place, or the publishers and so on? And that's what a relational database does. So that's the thing this is basically what I wanted to tell you about, which is that being able to have so many people, right? And being able to, begins really with being able to read a text using regular expressions, coding the text or tagging it, putting that into a relational database, and then being able to design queries to call that information up as you please. Now, I have enough time, I can do it all again. That's a joke.
Yeah, I think that was a really fascinating presentation. I think right now we're open to Q&A. So if anyone has any questions you want to ask Professor Bol, feel free to go right ahead.
About this or anything else?
So I have a question about the regular expressions.
Right.
I know you briefly touched on that. I was just wondering, like, is that something that you have to create by hand? Because I've used regular expressions before, and I'd imagine it would be quite time consuming to generate them for all these different types of texts.
So let me give you an example. In this text, we have a place name, right? In dark blue. That's the name, Wuzhou is the name of a prefecture in the middle of Zhejiang province, which is south of Shanghai. We happen to have a list, which we get from the China Historical GIS, of all the prefectures and counties and provinces in China through history, right? And so what we do is we write a regular expression that says, and this is why Python is important, right? You can use regular expressions, in Word or in Excel. I mean, Microsoft, actually, it's wildcards in search, which is another form of regular expression. But what we would do is we'd say, here's a library of all place names. Run through the entire text looking for matches. Begin with 4 character, 4 Chinese character. This is a 2-character name. 4 character names, 3, 2, 1, or whatever, right? And go through and tag each one of those and give it a code number. And there's another wrinkle to this, which is it has to be the right time period, but give it a code number. So if you have the list of places, writing a regular expression is not a big problem. Basically, you make a Python library with the names of all the places. What the time-consuming part was the iteration, look and improving on it to try to be more accurate. So in the use of regular expressions, we have, there are 2 terms to keep in mind. One is called recall, and the other is precision. What recall means is suppose in this text, right? In this character, and what you see on the screen here, you had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 possible data points or strings that could be tagged. Right? And suppose you get all 18. That would be 100% recall. But it's possible that you would only get 15 for some reason, right? That your libraries didn't contain some of these words. Or that it missed some, that it took this term right here, wenxian, and thought it was the name of a person, right? So there are lots of things like that. So then your recall might only be 80%, or it might be 110%, right? The second question is, so you want to get recall close, as high as possible. And then you want to see how many of what things you recalled are correct, and that's precision. So if I find 110% of the possibilities, then clearly my precision is down, right? Maybe I only have 80% precision. But what I want is maximal precision and maximal recall, because I don't want mistakes. So I prefer lower recall and higher precision. So we found that by and large with dates, with Chinese dates, we have 100% recall and 100% precision. But with social associations, turns out it's almost, with a few exceptions, it's extremely difficult to use computational methods to track social associations. Right? It's just too complicated. The language is too various. The phrasing, the grammar is too variable. But lots of things we can get, but social associations are a difficult one.
I actually have a question about this project. Uh,
Yeah.
so it seems like there's a lot of different types of analysis. There's the textual, spatial, and then the network analysis. So I'd imagine that there's a lot of data that you have to like manage in order for this project to work. So how did you like manage the scale of this project? Because it seems like there's a lot of data to hold. Was there a collaboration with different people who are familiar with
Yeah,
like,
so if you go to the website, you'll see the history of this, and all of our collaborators, people who contributed data sets. We work with Academia Sinica in Taiwan, with Peking University in Beijing. Um, we have lots of collaborators, and it grows over time, right?
right?
So we have people who have had a big project on the 18th, 19th century, and they're giving us an enormous amount of data, right? We had somebody who did a major study of bibliography, and they're giving us 38,000 book titles, right, with authors. And that's really how we work. Gradually, you put it into the database. And once it's in the database, then it's fine. You can do anything with it. But the challenge is something called disambiguation. Disambiguation is this. Suppose you have two people with the same name. How do you know if they are the same person or different people? Well, you say, if I know their birth and death dates, I know where they were born, and I know their gender, and I know, so let's say birth, birth, death, place born, gender, and name, I'd have no problem disambiguating everybody. But in practice, we don't actually know, right? If that's the same, we don't have all 5 data points for every person. Sometimes you only have 1 or 2 data points, and they don't match up. For one person, we have 1, 2, and 3. For the other person, we have 2 and 4, and we don't have all 5. So what do we do then? And that is gradually, as you get more data into the database, that sorts itself out. But disambiguation is a major problem even today in modern data sets, right? When the government is, or bibliographies are allowed, are people with slightly different names the same person or not? Or if they have the same name, are they the same author or not? The same taxpayer or not, and so on. You can imagine if you go to a phone book. Well, you don't have phone books anymore, but in the days when we had phone books, you could go and look for Joseph Smith, and you could find thousands of people in a big city named Joseph Smith. How do you disambiguate it if you don't have their addresses? So that's a big challenge, an ongoing challenge. But it's better to have duplicates than to take 2 different people and treat them as one. The duplicates can be sorted out eventually, but if you treat 2 people as one, then disentangling them means you have to go back to all the original sources and do the research, and no one wants to do that. Okay?
I guess in general, what were some of like the biggest challenges with this project?
Well, disambiguation is one. Trying to figure out social associations is another. Luckily, in the Chinese case, we have people in Chinese history did a lot of writing. And their writings were collected, sometimes after their death, sometimes during their lifetime. And much of the kind of writing they did is what's called occasional writing. That is, it was written for a specific occasion. I write you a letter. You are building a house and you come to me and ask for an inscription to honor your house. You write a book and you ask me for a preface. You're going to see somebody and you ask me for an introduction. Right? You ask me for a recommendation letter, right? These are all social connections, and they end up in people's literary collections. So if the literary collection is digitized, or if you have an index that draws on it, you can, in fact, construct social networks. And that's why we were able to do such extensive social networks, because we had information from people's literary collections. You know, this is, in this one place, prefecture, over this 100-year period, we probably had 3,000 different connections between people. That's, you know, that's 700 years ago. That's a lot. Okay. Good.
I also have
Yeah.
a question.
Sure.
Yeah, so what are your next steps for this project? Are you planning on expanding it beyond Chinese history or staying focused on that? Or what?
So the next steps are the continued amassing of data. The database is being commercialized in China, which is, you know, means also that's being popularized. We have online systems and offline systems. We're going to have to go to something called SQL Server because of the amount of data that's coming into the database. And we're in the process of doing that at the moment. And that's a design architecture issue. We don't intend to include other countries. We already include other languages. So for example, Koreans or Japanese people that work in China in the past, in the Tang Dynasty, for example, we can put their names in. We can include any name, any mode of writing that's in the UTF character set, which is most of them in the world. So we've included that. And the database structure, we've lent that to other people working on other countries. But given the code tables we have, the database structure could be used for, is being used for Japan, for example, but the code tables wouldn't fit. And the Europeans are very interested in this and are looking at it and figuring out how they can create similar things. The prefecture that I was talking about, by the way, is right down here, right in the center of all those red dots. That one place, that was all those examples. Okay, guys? Good. Thanks a lot. Good meeting you all. Good luck with those of you who are still waiting to find out where you're going to college. Those of you who've already got in, congratulations. And maybe I'll see you someday. Okay?
Okay. Yeah.
Bye-bye.
Thank you so much for coming and taking the time to do this. It means a lot for this club.
Glad to help. Glad to help.